first part of this question asks you to copy and redraw the diagram in your writing book. Now, I've cheated and kind of already done that. The other thing that you need to do when you're copying out is always make sure that everything that they've mentioned in the text is actually drawn onto the diagram. The only thing they haven't mentioned in on the diagram that is in the text is the fact that there's a square, which is this one here. So I'm just going to give myself some markings and remind myself that that's a square. They gave me the one there, which actually makes that one the other pieces of parts of things, so I probably won't bother with those at this stage. First part of this question actually asks us to prove the triangle FCB and BAT are similar. So whenever I get a similarity proof, I really like to highlight the two triangles they're talking about. FCB is this one, and BAT is this one. So for triangles to be similar, you need pairs of sides that are in common ratio and an angle, or more than one angle matching. So I can see here that quite easily that I've got two right angles. And if I look for maybe some parallel lines, because there's lots of parallel lines going on here, maybe I can find an alternate or a corresponding. Now between those two triangles, I'm noting that AT and CB are parallel. So if they're parallel, then the line joining them, BT, is actually a transversal in alternate position, i.e. this one is the same as this one. So that should be enough to write a proof out. When I write my proof, because it's all pretty straightforward, I can just start by copying down the way they've said those triangles. And then I state my two angle facts. I only need two angles for a similarity equiangular, because the third one will be by default. So and then I can throw my therefore line in. And because I've written these above, it's pretty easy to just reread them. And that's enough to finish that one off. Next part of the question asks for another pair of similar shapes, so TSA and AEB. So I want to prove that this one is similar to this one. Oh, I remember now. I was going to say that it's always really important to make sure that you've already planned out your whole process before you start writing. So if you've thought it through and then you start writing, then you're going to write a whole lot less lines. If otherwise you're just going to start writing, oh, this might be equal to that, this might be equal to that, and you don't really get anywhere for ages. Now for these two to be similar, again I've got a pair of equal angles with those right angles, but I don't have a transversal between any parallel lines that join them, because this pair of parallel lines at either end, like for instance, this one doesn't actually go all the way through. So I can't use that, but I can make note of this right angle here. If I do that, I could recognize that BAS is an exterior angle of this triangle here. And being an exterior angle, it would be the sum of the two opposite interior angles, meaning this one, and why don't I call that theta? So if this plus theta equals this, and this has got a 90 in it, then this must also be theta. So in order for us to write our similarity proof out, we're first going to have to write a proof for that. So angle BAS equals 90 plus theta. Oh, always leave lines here so you can remember things and write them in later. Let angle ABE equal theta. So my aim here is, if I'm letting this equal theta, I've got to write some stuff until that equals theta. After I've done all of that, I will write my similarity proof. Now I know that BAS equals 90 plus theta because it's the external angle. And this external angle is the sum of the two opposite interior angles. And the reason it would equal 90 plus angle TAS is just because that's their adjacent angles. Therefore, angle TAS has to equal theta, as I've said that it equals 90 plus theta. Now I'm ready for my proof. I'm going to write given for my 90 degrees because it was literally written on the page in the diagram, and it was just a fact that they gave. It wasn't like I extrapolated given from it being part of a square. It was literally just these are at 90 degrees. So that's when given applies. Proven above is my friend for similarity proof. As I explained, it makes this whole thing flow much better. Okay, that one's done. Last but not least, it's saying find h in terms of x and y. So you'll see h is part of the orange triangle set, so is y. And I've got x is part of the green triangle set. So when I've got two triangle sets like this, it's really important to notice the overlaps, also beautifully shown up in the highlights. I could see that TA overlaps in both of them, so I'm just going to give that another letter. So I've got x, y, maybe I'll call that z. And AB also overlaps, but as we noted the square before, we also know that that is 1. My favourite thing to do when I am redrawing triangles, or when I'm doing similarity ratios proofs, is I'm actually going to redraw triangles, T, S, A, and when I redraw its pair, I'm going to redraw it the same way around. So with a theta there, right angle and theta, so the right angle was E, that was B, and that was A. Now I can see really quickly which part goes with which part. AE is Y and EB was nothing, but that was 1. Then I might have to say let TA equal Z because I created Z. Also keep making space for things. And I could say here that H on Z equals Y on 1. And I'll just leave that there for now because I'm not sure what I'll do with it next. Same process over here for the green triangles. Put the right angle there, dot up there, so A, T, B, which means I need right angle and dot for the small one, C, F, B. CB was 1, FC was X, and over here AB was 1, and TA was Z. So here I could say Z on 1 equals 1 on X. Now, the beauty of having Z common between the two of them is now I could actually solve these equations simultaneously. So this one's basically Z equals 1 on X, so I could put 1 on X into this equation. H over 1 on X equals Y. Now if I've got a 1 on X here, I could actually just times by 1 on X to the other side of the equation. Simplest way of getting it out. And what I have done now is found H in terms of Y on X.